Okay, so here we have the first of our slightly trickier, I guess, core 3 type trig equations. Two parts: expand 2 sine theta plus 30 degrees and hence solve root 3 sine theta plus cos theta equals root 2 in this range. If you're trying to get the most out of this, please pause the video now and spend a couple of minutes trying to actually solve both parts of this problem, see whether you can do it. Then unpause to check if you're right. Okay, first part, fairly straightforward. We have to remember that sine of a plus b. Oh wait, let's hope we can remember that. Sine of a plus b is sine a cos b plus cos a sine b. So this becomes 2 lots of, and then we get sine theta cos 30 plus cos theta sine 30. Okay, so that's using the addition formula for sine. It's really important that we are sort of fluent with those addition formulae. We can then expand that out. We know the value of cos 30 degrees, we should know it, it's root 3 over 2, so this gives us root 3 sine theta plus, and, oh, terribly sorry, I said the right thing, wrote the wrong thing, cos theta sine 30 is what this should be. Sine of 30 is actually a half, so when you bring out the 2 from the brackets, you just get plus cos theta there. Okay, so these two things, this thing in blue and the thing on the left-hand side, are equal for every possible value of theta. And now we can see how this relates to part 2 of the equation. Hence solve root 3 sine theta plus cos theta equals root 2. Okay? So without part 1, this is a deeply terrifying equation because it's got 2 different trig functions in it, and it's very hard to see how to get that to just one trig function. There's a trick where you divide by cos, but it doesn't work, because you get root 3 tan theta plus 1 equals, really scary, root 2 sec theta. So the trick is to use the previous part, and notice that the thing on the left-hand side is actually just 2 sine theta plus 30 degrees equals root 2. And now we're back into familiar territory. Sine of theta plus 30 degrees equals root 2 over 2. Let stickman equal theta plus 30. So we've got sine stickman equals root 2 over 2, and we adjust the range for stickman. So the range for theta was 0 to 360. Stickman is 30 more than theta, so you've got 30 less than or equal to stickman less than 390. Fantastic. Sine inverse of root 2 over 2, it's one you should really know. If you don't know it, it turns out to be 45 degrees. So you've got stickman equals 45 degrees. Other solution for sine. For sine you do 180 minus, or stickman equals 135 degrees. And you can add 360 to either of these solutions, but doing so would take you instantly out of the range for stickman, because 360 plus 45 degrees is more than 390. So now we find x again, theta again. So it turns out that since stickman was theta plus 30, theta equals stickman minus 30, so theta equals, these are our final answers, 15 degrees, or 105 degrees. And at this point it would be well enough to actually check, maybe using your calculator, that these two values of theta really do satisfy the equation here. So there they are.